Hey, what's going on YouTube? We should be live if everything's hooked up correctly. I think so. What's up? Welcome to a very special stream. This is going to be a trial run, a practice run, one might say, for a brand new channel in 2025. So, as you can see above, JC Practices Math. Go follow it. It's available right now. There's zero videos, zero live streams, but all of this is going to transfer over there. If anybody's watching this after the fact, right now I'm streaming to my guitar channel, JC Practices. So I am a classical guitarist, and I've been running live streams just like this for the last 4 years, starting on Twitch and then moving over to YouTube. And so a fun twist is we are going to be listening to my guitar recital that I ran on Monday. So that's going to be the background music for the stream. This is going to be fun. I'm going to have fun. I hope you do too. If you are a subscriber for my guitar content, please do not unsubscribe because of this one random video that's off topic. I promise we will get back to the guitar streams very soon. In fact, tonight I'll be running my next one at 8 p.m. Eastern. All right, so let's start the guitar recital, and I'm going to talk through this idea. So this is live. Everything I do is live. And part of that is because I am practicing life skills, the ability to talk to a camera, charisma, one might say. That's what I'm shooting for. And the ability to just play guitar in a moment's notice or to explain a math concept to a student in a moment's notice. So here's my little agenda that I did prepare. We're going to go through an intro. And then not all streams are going to be like this, but today the topic is going to be math for kids, which I think that there's a lot of really fun stuff. We're probably only going to get through the first 3 of these. I'm going to try to limit the stream to an hour, and we'll see how it goes. But I would like to maybe briefly talk about these other 2 topics. And then, maybe I'll talk a little bit more. I just briefly mentioned that this is going to be a practice stream that we're going to turn all this into. And then we're just going to have our outro. But for the most part, let's get started. And let me pull up chat to make sure to see if anybody's watching. All right. So, we're going to have cats as well. I should say that. Hello, my name is John. Why should you care? That's an important thing in any kind of presentation. Why should you care what I have to think about math or guitar or whatever? So unlike guitar, I did formally study math in my undergrad. I went to school, got a bachelor's in math. I was ready to go to grad school, but then kind of at the last minute, I rescinded my applications, and I was like, you know what? This brand new iPhone thing, I think it's going to change the world. I think I really want to learn how to program for the iPhone first. And just honestly, I saw math being a really difficult career. As much as I love it, just life situation, for whatever reason, it just didn't feel like it was the right time to go to grad school. I don't know. I'm thinking about it again a lot. I think that it would be really rewarding to do. So I'm passionate. I love mathematics. I especially love pure mathematics. So we'll be talking about that a little bit today. But yeah, here's some of my background. I studied math formally, but then for the last 10-ish years, I've been working in Silicon Valley as an iOS developer, I should say, specifically. So I love the iPhone, and it kind of matches a little bit. One of the reasons that I decided against grad school is I personally purely love pure math. It's so much fun. It's gorgeous. It's one of the most beautiful things in the world. To me, it's math and music are the 2 most beautiful things in the world. But I realized, if you go into pure math and you get good at it, there are like 10 people in the world who really understand what you're working on. And you get to talk about the stuff that you work on with like 10 people. I want to build things that I can show my mom. I want to be able to point to this and be like, here, look at this. Like, this is improving your life. Like, I want to be able to like share stuff that people can look at, touch, feel. And the iOS App Store was just coming out right when I was graduating. I graduated school in 2012. So, I mean, it wasn't like brand new, but I followed iOS development from the very beginning throughout all of college. The iPhone came out in my freshman year in fall 2007. And yeah, anyways, let's stop talking about programming. But yeah, I'm an iOS developer. I worked at some of the big FANG companies. I worked on iMessage at Apple. I worked on payments at Lyft. And then most recently, I was an iOS specialist at YouTube. So Google has a lot of people who are great at Android. It's a little bit more, just a little bit more of a rare skill to be like a specialist in iPhone programming at Google. So I worked at YouTube. It was a wonderful job. I built the widgets. So on the home screen, there's like these really simple widgets that can launch you directly to the search field and other things. I built those. I really like led that project. There was a team, but I led that. Google went through layoffs, and it's coming up on 2 years now. My entire team got hit by layoffs, and at this point, I took the opportunity to go independent. I am trying to build some of my own apps, but then beyond that, I kind of want to broaden outside of just programming. I love private tutoring. I still say that my favorite job to date was running the math tutoring center for 4 years throughout college. I ran that, I trained the tutors there, I did calculus, I did all college math. I love tutoring. I love one-on-one teaching. I really like teaching. Some of my favorite work at the big companies was always like mentorship of junior programmers. I call myself a deep hobbyist, both in guitar, but also in math, meaning, and there's going to be a video coming out about this at some point. What do I mean by deep hobbyist? In short, I mean a hobby that you will pursue the rest of your life. It is a craft. It is something infinitely deep. Everybody I know at the big companies has a deep hobby. A lot of people get into chess or Brazilian jiu-jitsu or something else, but you have to have something besides work. Yeah, and anyways, that'll be a video for another day. And yeah, like related to that, I think I'm really passionate about the idea of deliberate practice. So it's something, I just realized my feet are showing up in the horizontal video. Whatever, let's leave it in. I'm multi-recording, dang it. Okay, whoops. Well, I forgot to hit the record button until right now. Whatever, we'll clip the other part or something. But yeah, so deliberate practice. I love the idea of deliberate practice. It, like, getting turned on to this idea, like the pop culture version was Malcolm Gladwell, I think. That's like the pop culture version of this idea, and it's like the 10,000 hours idea, 10,000 hours to become a master at something. But I'm blanking on the name right now of the authors, but go read the book Peak if you want to like read the original research that Malcolm Gladwell was kind of like watering down a little bit. This is really just the idea of like craftsmanship. That's another way to put it. Craftsmanship. And it's really important, it's super obviously important in classical music, like practicing scales, for example. But it's also just incredibly important in math, in programming, everything. I really honestly credit my career to the idea of deliberate practice. And that's why my channel is named JC Practices. I love the idea of practice. So, I find it really important that everything is live. I will probably edit this video and put it up on the new channel, but I'm going to try to lightly edit it because at the same time, I'm trying to practice live skills here, y'all. Yeah. Also, I see we do have a couple people who've tuned in already. Thank you. How's it going? Let me know how the audio levels are, especially. If you want the background music up or down, just let me know. Cool. So let's continue. So, as I said, today's topic is going to be math for kids. I've been private tutoring a couple of kids recently, and I'm just finding it so much fun to try to teach them some really cool math that I wish I saw when I was a kid, or in high school, or ever. Like, I didn't see a lot of this math until I was in college and studying it, as a pure math major. So let's talk about the idea. This right now is not the presentation to kids. This is talking about the concept to a fellow teacher or trying to pitch this stream to you, I suppose, as a viewer. I should have reordered these two bullets, but as I just said, I had never really seen the concept of pure math or the idea of math for fun, that people do math for fun. Until I was in college. Throughout high school, I was okay at math. I was a B+ student. I'd say I was a B+ student always, but including in high school. I took AP Calculus, so I was on the advanced track, and I passed that course. But it wasn't until, I went to college to study engineering. Specifically biomedical engineering is what I was really interested in, tissue engineering and other really cool stuff there. But then in my first semester, one, I realized I hated chemistry and I'm not good at it. But then two, I fell in love with math once I took, let's write this down, linear algebra. This course is incredible, and I wish I had seen linear algebra when I was in high school or earlier. I had always just learned math as this idea that it has to be applied. I think that's how teachers teach math. They teach math as it must be this applied idea. You have to tell kids why this is useful in the real world. Well, one way that something can be useful is just because it's beautiful and fun. You can do math as a hobby, and I had never seen that before. So, I think exposing kids and students, high school students, to that idea, this could be your deep hobby. This could be something that you do the rest of your life for fun because you love it. Not necessarily because you may or may not study engineering. In a sense, that is more useful to a lot of kids. A lot of high school students know that they don't want to study science and engineering, but the idea that maybe I'll do this for fun later, in a sense that's more applied, right? I don't know. I think that there's an argument to be made there. So I think that number theory is a perfect case of this. Depending on the level of kid, you need to really hand wave. So hand wave is mathematicians speak for skip the details. Skip the gory details. You don't have to teach them everything, but you can state the idea of a lot of math. Anybody else who's watching this with prior experience and love of math will recognize what I mean by this. And this is a perfect example. This was solved in the 1990s, y'all. I had never come across the idea of an open problem in math until I was in college, I don't think. Like, I mean, maybe I had heard of it, but it never really, like, settled into me as an idea that, like, oh, wait a minute, math isn't solved. Like, math is still evolving. Math is, like, people are still learning or, like, studying and inventing and discovering new math today. And there are all of these unsolved open problems. I think that's phenomenal. And I think that if you expose a kid to that idea really early on, like when they're in second grade, that can set them up for a lifelong better, what's the word that I'm looking for? Just a better path. Just set them on a better path than otherwise. And related to that, math is hard. Math is infinitely hard. It's just like this pure field of logic that's like this art form. Like, we keep discovering and inventing more complex forms of math that, I don't know, like, the point is that it's hard. That's why it's fun. That's why it's beautiful to some people. Not for everybody. I'm not saying everybody should become a pure mathematician, but the reason some people find it beautiful is because it's hard. And so don't worry when you get stuck and you're in trigonometry class. That is hard. That is a hard concept to learn. But you'll get through it, and at some point, you may develop the love of, like, you're stuck, and then you solve the problem, and then you get that reward that was like, oh, I was totally stuck, but now I know, and now it feels easy. Now I understand this problem. So, I like to show that to kids early. Part of that is open problems. Some of these problems you can state and you can explain it to a kid, and then tell them that lots of mathematicians have spent many hours trying to figure this out and spend entire careers trying to solve this problem and haven't been able to. I think that's incredible. So don't talk down to kids. Don't pretend as if you are this, like, master at math who, like, I know everything. And yeah, that kind of goes along the idea of these live streams and this live practice. So, like, people who know me for my guitar content and my guitar channel, you'll know that I am literally just practicing scales or live learning all of the guitar music that we're listening to right now. And I'll get stuck and I'll make mistakes, and I think that all of that's going to happen all over again if we do this math stream. So let me know in the chat section, in the comment section, does that idea sound interesting? Like, some of it's going to be a lecture, like right now, but a lot of it could be like a study stream, like a Pomodoro stream. Like, maybe I'm just, like, here scribbling on or off camera and trying to solve a problem. Maybe we're all doing a 30-minute work block together and then take a 5-minute break and I try to talk through, like, what I was just working on. You know, just kind of going back and forth between, in a sense, it's kind of like in music, performance versus practice. And for a lot of math, you need to practice quietly with deep focus. And so this is math for kids today, and it's going to be math that I know and I can explain easily. But the other side of this entire idea is maybe I'll be learning math for myself as well, and trying to learn some things and getting totally stuck at 90% of the time, just totally stuck. All right, let's just get started. Let's finally get started. Fibonacci. Let me know. I see we've got a few viewers. Thank you for tuning in. How's it going? My name is John. I hope you enjoy this. I'm normally a guitarist, and we can hear what some of my guitar that I work on. So, let's get started. This one most kids see. So I've been showing it to kids, and some of them recognize it, others don't. But I don't know. I feel like I see kids in the 5th grade up kind of range. Like, some of them recognize this. But, like, I think that you can explain it to a 2nd grader. So I like to think of this as, like, literally I tell kids, like, it's a game. And, like, you're learning addition right now. Like, before you even teach a kid subtraction, like, here's a fun way just to practice addition. Rather than getting boring worksheets with problems that aren't motivated, this is a problem that is motivated by some beautiful things that I'll get into. So, I think I typically tell kids that even in a meta way. Like, this is just a fun way to practice addition. So, y'all may or may not know this. But, like, a lot of kids that I've seen, they'll get problems like, what's the pattern? What's the pattern here? And they'll get a problem like 1, 5, 9, 13, ... Like, what's the next here? They would probably get a problem that shows something like fill in the blank, I want to make sure I don't get off on this because that would be embarrassing. But spot the pattern. Somebody in chat. What is the pattern? Come on. I'm gonna give it 3 seconds. 1, 2, 3. All right. So the pattern is +4. Each time we're just adding 4, right? So 13 plus 4 is 17. 21 plus 4 is 25, right? Well, so this is the idea of sequences. And kids get exposed to the idea of sequences. I like to show them this cool sequence. I'm like, okay, I wonder, can you find the pattern here? And I'll give them a few, and then they'll get stuck. And then they'll be like, ooh, wait a minute. These add by 0. This one adds by 1. Usually they just don't even see that, and they get stuck, and they're like, huh. And I'm like, let me know when you need a hint. It's okay. You might not get this one. My feet are showing up in the horizontal recording. Let me get them out of there. So I'm like, let me know when you need a hint. It's okay. Like, you probably won't see it, and it's okay. And then they're like, okay, I'm stuck, and this is a 2nd grader or whatever. And I'm like, okay, what about this? And they're like, well, I see it's getting bigger. And I'm like, okay, remember these types of problems that you've seen before? And it was +4, or this other kind that's like 1, 3, 2, 5, 4. Some kids have seen this kind of sequence. Like, oh, that one was +2, -1, +2, -1. Oh, shit. Whoops. Also, pardon my French, I am going to be swearing like a sailor sometimes. Whatever. 2, 4, 3. 1, 3, 2, 4, 3. +2, -1, +2, -1. Some kids will see that and, like, they'll be able to figure out that pattern. Like, oh, it's kind of like those. And then I'll be like, do you see the pattern now? Like, and they're like, no, still not. I'm like, okay, let's write them in. Like, +0, +1, +1, +2, +3. Hey, that's proof. That was my voice. We're playing guitar in the background. And then they may notice, or they may not, and then, well, here, we can see, and then I would just draw this 1, let's see, or this 2 popped up here, and it popped up here. this 3 popped up here and it popped up there. You know, oh, wait a minute. And then this 1 popped up here, this 1 popped up here, this 1 popped up here. So we could maybe draw a line. And then, so this one, probably going to be a +5. Okay. +5. 8 plus 5. What's that? 13. Right? And then they're just like, oh, cool. Okay, so it's growing. And then this one's probably going to be a +8. 13 plus 8. And then ... Right? So that's one way to present this. Like, show a kid the sequence, start with a few examples, and ask them to see if they can spot the pattern. For a certain type of kid and a certain age or grade level, maybe that's the approach that you do. Or with another type of kid, maybe you just immediately start out saying, okay, I'm going to create a game. We're going to start with these two numbers, and we're going to add those two. What is 1 plus 1? Well, 2, that's easy. All right, well, what about 1 plus 2? 3. Okay, what about 2 plus 3? 5. 3 plus 5? 8. And 5 plus 8? You know, and then they start, depending on the age of the kid, they might have to start thinking like, oh, I have to add beyond 10, and there are tricks that they've learned. Oh, and now what about 8 plus 13? And then like, ooh, 21, and then 13 plus 21. And then some of the kids need to start thinking, and then 21 plus 34, what's that? Ooh, 55. And, you know, this is a cool way to just start generating harder and harder little addition problems. So if you're just trying to practice math and practice your addition, you could start with this. This will generate some fun little numbers to practice. 34 plus 55. You know, at some point, anybody's going to get stuck, and you're going to have to start thinking, right? Because these numbers are just going to get bigger and bigger forever. Yo, what's going on, Jeffrey? Good to see you, man. How are you? So we're, as I said in Discord, we're doing something different today. We're doing a trial run. We're practicing the concept of a math stream at the moment. And we're also listening to my guitar recital from Monday. Let me know how the audio level is, Jeffrey. If my voice is... Yeah, just let me know if you want me to turn up or down the background music. Okay, so now at this point, you know, a second grader is probably going to have to start thinking. And at some point you can start to, like when they get stuck and they want a hint, this is a great time to start showing some mental math tricks, right? Like, oh, well, that's kind of tough, but what about this other problem? 55, what's 55 plus 90? Some kids made, the mix sounds perfect, great. Okay, I was literally just guessing at the dial numbers. All right, so, well, what about 55 plus 90? They may or may not be able to do that. Like, well, if we add 90, then we just need to subtract 1. And then 90 minus 1 is 89. So this is the same number. They may or may not know that. And if they aren't able to do that, you could do, okay, well, what about 55 plus 100? And then we'll deal with this 11 after. A lot of people are going to be able to mentally, not just kids, but me too. You know, like this is easier for me. 155 minus 11, 144, right? Wait, no. Yes. So 155 minus 11, 144. Cool. So it's a cool way to generate some mental math problems, I think, and show a lot of people some mental math tricks, which is cool, I think. So I don't have it next to me, unfortunately, but I got a book called Shortcut Math, And so on this channel, slash the new channel, JC Practices Math, go subscribe, y'all. We're going to be working through textbooks as well as giving lectures or like little like practice demonstrations like this. I'm literally just going to solve every math problem ever. And thoughts on Equations of Beauty by Andy York. Great question, John Cesar. It's a beautiful piece of music. Andy York, man, I really want to learn his music. I don't know. I mean, without studying the music, I don't know the... let's take this little aside. Because a viewer, shout out to John Cesar, go follow him on YouTube. Great guitarist, just asked about Equations of Beauty by Andrew York. Okay, I have to admit that my first thought, yeah, please do. That would be great. Have anybody stump me. Like, I'm going to be stumped. I'm not great at math. I'm not great at guitar. I'm equally as good at math as I am at guitar. Like, I could probably get into a grad school, but I wouldn't have a successful career. Does that make sense? That's why I decided not to pursue research math back in the day. So Equations of Beauty, this is one of my favorite guitarists. I really like this suite, and I want to learn it from Emilio. The Newman suite is gorgeous, and it's one of my favorite pieces of music from last year. I heard Equations of Beauty, which is another piece of his. I heard it for the first time like about 2 weeks ago. And it's because he posted on Instagram like a throwback post or something like, 2 years ago or 4 years ago, I posted this, and it was early in the pandemic. So I've only listened to it exactly once, and I thought it was beautiful, but I didn't like the video at all. I thought the video was really cheesy. I'm not gonna lie. Like, no shade, because it looked really impressive. Like, mathematically, like it's clear that he generated a lot of the computer visuals himself, and there's a lot of cool math that went into that, like, in the code. But I don't know. It like the final output doesn't look as beautiful as it truly is. So I don't think everybody is going to appreciate how beautiful that video was. Anyways, so the music was more beautiful than the video. I'm sure that the code was great. Last thing I'll say on Andy is he has an incredible video about partitions, which is one of the math concepts I like to show kids. Where is it? Right over here. And I don't think we're going to get to it, which is what that blue line means there, but I don't think we're going to get to it today. But he has a really cool demonstration of partitions and applications of that to acorns. Or like he like presents this idea of partitions with... He presents the idea of partitions demonstrating it with acorns, and then talks about applications of it to music. Andy's very good at math. Yeah, like he has done some legit research level math. In particular, this on partitions, he proved. Yeah, this is a cool aside. I'm just gonna lean into it. Why not? Let's quickly get into this. So, the idea of a partition is that you can write down a number by partitioning it in different ways. Like, think of like, I don't know, a candy bar or something that has like a long candy bar. You could split it into 4 one-sized pieces, or a candy bar you could split into 2, or you could, eat 1 and then leave 3 for later, right? Like, etc., right? So all of the different ways that you can split that candy bar of length 4, let's write them all down. 4, 3 plus 1, 2 plus 2, 2 plus 1 plus 1, or 1 plus 1 plus 1 plus 1. So these are exactly all of them, because we're not going to consider like swapping the order different. Like, we're going to consider that the same, like one piece of 3 plus one piece of 1. Anyways, it's not at all clear why that would be interesting, but just like about 100 years ago, there's some beautiful math that was discovered by an Indian prodigy, genius mathematician, Ramanujan. Okay, like about 100 years ago, he proved some results that are beautiful and too hard to explain right now, but you can count, like I'll say, I forget, you can count how many partitions there would be of 4. And there are exactly, if I did this right, yeah, there are exactly 4 ways to split up the number 4. I forget it off the top of my head, but I want to say it's 7 on 5. And then they get like huge, really fast. Like the number of ways you can split something up gets enormous really fast, and there's no reason to think that there would be a way to estimate or like to get a formula for this. This dude discovered a formula about 100 years ago, and it's really beautiful. He discovered an estimate, and it's like kind of mind-blowing, and has opened up a lot of open questions, like unsolved math problems. This dude was famous for coming up with a lot of open like conjectures, which means like I think that this is true, but he didn't find an actual proof. So we are still in awe in trying to like prove a lot of the predictions that this guy made. So back to Andy. Andy found another formula to estimate this, and he improved the estimate. So he found like a new estimate that's a little bit better than the old one. Okay, cool. Mohan integration. Can't this be arranged by permutations and combinations? It's exactly that. It's like this is a combinatorial math. The partitions, and I don't know that much. Like I just know surface level. We're close to reaching my limit on this. I can next time talk about odd versus distinct, and this is something I do teach the little children that I work with. This is a beautiful piece of math that is closely related to all this. Anyways, this was known about 300 years ago or something. But this thing that this other guy did is about 100 years ago. Andy is a recreational mathematician, or he's like a deep hobby, y'all. And he improved the estimate, which is really, really cool. I've skimmed the paper, but I haven't like really deeply understood it. All right, so yeah. Ramanujan is the man who knew infinity. There's a book named that, so everybody should go check that out. So, all right, let's take a chat break for a second here. Maths class, yeah, music. It is maths class today. The concept is that for those who've played video games, especially from the last 15 years or whatever, I'm thinking of prestiging. Like in video games, you can get to a certain level in Call of Duty or Universal Paperclips or something, and you can get good at some level, and then the game will offer you, do you want to start over? Do you want to start from 0 and have no weapons and no items and start all over again? you'll get a 1% improvement if you do. And that's a concept of prestiging, like restarting a game and getting a little bonus if you do it. I'm thinking of doing that. So I've learned a lot of skills. The fact that I can do all this live right now with YouTube from my guitar channel. Go follow JC Practices Math. Shoot. There we go. Okay. All the way at top left of the screen, JC Practices Math. It's a new channel, 0 videos yet. This will probably be edited and put there. Cool. So let's see other chats. Yeah, music. You're from the land of Ramanujan. He's brilliant. Like, it's such a cool romantic story too. The topic today right now is math for kids. That's what I'm trying to do right now in this. I'm showing some of the things I like to teach little like second graders right now. It's that there's so many beautiful stories in math, and Ramanujan is one of those. That's like, there was this guy from India who, like, he says that he discovered all these predictions, all these like hypotheses in a dream from gods or something like that. I don't remember the details, but like, and we're still trying to understand the math that he predicted, which is super cool. All right, so let's see. Honestly, if I could do it over, I probably would have studied math and engineering instead of music. It's not too late, and I know just the tutor. jcpractices.com. Go send me an email. Yeah, I mean, I really honestly think it's not too late. A lot of the people I worked with at Apple, Lyft, and Google, a lot of the best programmers I've ever known all had like a music background. There truly is something to... I don't want to say that there are math and music people. I don't think that that's accurate, and that's a really damaging idea that's just in our culture. But if you get good at one of those, you're likely to get good at another because it's a similar skill. Like, I think that's an important thing. It's a skill that you can develop. And music, yes, this is Fibonacci. So we're going to get back to Fibonacci here. So I've been showing kids this, and it's a fun way to just like do some addition practice. And I haven't heard it, but I like to imagine that like the right kid may go home and just try to practice this and like someday be like, look, I got it to 1,000 number, like to the 4-digit numbers. Like, somebody can just practice math as long as they want, and it's fun in a way. It's like kind of like a game, potentially. All right, I'm a medical student. I'll take leave. Go on, bro. All the best. Thanks, man. Let me know, what do you think overall? Thumbs up or thumbs down on this as an idea? Not necessarily for you, but maybe for somebody else. Does it seem interesting? Anything I can improve? Good to see you, music. So I think that's all I'll say about Fibonacci. It's just like a good way to generate some numbers that are motivated a little bit. If the kid knows about pi and how some people memorize these digits, 14159, that's literally all I know. I've never cared to like memorize the digits of pi. But some people know pi to like, whatever, thousands or tens of thousands or something digits, and they can just recite it like that. I like the idea of memorizing the Fibonacci sequence. That's a cool sort of thing to memorize if you're having trouble sleeping or whatever. Cool. Let's get to another topic, unless anybody has any questions. All right, music says overall thumbs up. That's great. I was joking about this with my partner. I think it's wonderful that Kaya is here sleeping. I like the idea that like Luna is the guitar cat, and like Luna loves the guitar streams, and Kaya is here for the like thinky intellectual streams. That's funny. I'm happy that that's happening right now. So I have 2 cats, and they're both wonderful. Obviously, bro, anything can help someone, especially what you're doing. Cool, man. Thank you. Teaching maths to some kids and adults. Today is kids focused, but yeah. I used to be scared of maths. You might help someone to learn in a fun way. Yeah, man. Yeah. Pi value equals, can I have a cup of coffee? I don't know that. Mohan, can you explain that one to me? Is there a mnemonic, like a way to memorize pi based on can I have a cup of coffee? Also, shout out to coffee. I love coffee a lot. Too much. Number of letters. I guess he meant infinity. I don't follow. Let's move on to Pascal's triangle, y'all. Okay, so this is another fun addition game for kids or anybody. I like to show them this. 1, 1, 1, 1, 2, 1. All right, so the game that we're going to do here, for the right person, you can ask, like, can you see the pattern? And I'd be pretty impressed if somebody saw the pattern already. I don't know, maybe. Shout out in the chat if anybody who's seen this and who hasn't seen this. How about that? Who knows this one and who doesn't? Because there's some really cool stuff here. All right, gonna give it 2 more seconds. 1, 2. All right, so at this point, I would ask somebody, like, do you see the pattern? They'll probably say no. I'm going to write down 1 more. They probably still don't see the pattern. Most people don't. At least, like, kids don't. And I'll say at this point, like, okay, the game that we're going to do is every time we start a new row in the triangle, we're going to start with 1s on the ends. And then for every other number, we're going to combine the 2 numbers that are above it. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4, 10. 4 plus 1, 5. And then I'm just going to run through this a bunch of times, and I'm just going to generate like a bunch of little questions. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 15, 6, 1. And then I'm going to say the same thing, like, oh, like this is just like the other problem that I showed you last week. It's just, on the one sense, it's just a fun way to practice addition. And it's going to keep going on forever, right? Like this, we can do this forever. And at some point, it's going to get hard for anybody. Like, you're not going to be able to do this mentally. I can't do it mentally when there's 100 rows or something. No way. I'm going to have to, think about it. But it can be a way to practice math mentally and practice addition mentally. What's 6 plus 15? And some people can get that, rapidly, and then other people can't. And so just depending on the person, like if you want to drill addition skills with somebody, maybe they're weak at addition and you just want to focus on doing some practice problems. Battery almost out. Oh no. We'll figure out what to do in a second here. No cable. We'll probably just plug it in somewhere. Yeah, we'll figure it out as we go. So at this point, you could just generate a couple more rows and try to just have them practice some more addition. Like right about here, it starts to get harder and they like kind of stumble, I think. Or just have to think about it for a second. But then what I like to do after that is just like, okay, now there's some really cool patterns in this. And in a lot of ways, this is actually very useful. This was discovered by somebody named Pascal about, I don't know, 400 years ago, something, I forget. I don't really remember exactly, and it doesn't matter. A few hundred years ago, this person discovered this. And there's some really cool patterns that mathematicians are still looking for. in a sense, I would say that math is the study of patterns and trying to understand structure and why something works. Like we're always looking for patterns in numbers or more complex ideas that come out of numbers. So I wonder if you can see any patterns here. And it's really neat. Like some of the kids that I've tutored have found patterns that I haven't seen before. And yes, language of universe, exactly. It really is. I truly do agree with you there. So I usually do this on paper and pencil, so I'm going to try to stick to that here. I mean, I could use a color for the purpose of the string. Yeah, let's just use a color. But just imagine that this is all pencil. So one thing that I'll do is I'll give them a hint, because sometimes I'll see them often, kind of struggle a little bit on some of these. This is a good one where I would show them the mental math trick, 28 plus 56, and I'll see a kid start to write it, oh, I can't do that, I want that one in my head. 28 plus 56. Let's all remember how this algorithm works. 28 plus 56. 8 plus 6 is 14, right? Yeah. 2 plus 5 is 7, plus 1 is 84, right? That works. That works really well. No matter what, if you have a long number, this is the way to go, or grab a calculator. But if you need to calculate something like this, for me, it's faster, and I prefer to think of this as, well, what is 56 plus 30 minus 2? So 56 plus 30 is easy. That's 86, because I know 50 plus 30, 5 plus 3. So 86, and then I just have to subtract 2 from that. So 84. I can get to that way faster than I can, find my pencil to write it down on a piece of paper. And, a lot of these tricks I didn't learn until, I was older. I wish that somebody showed me that when I was young and learning addition to begin with. So that's a good moment to just, teach some mental math in context, not, as a worksheet dedicated to that idea of, learn this trick, learn this one cool trick that will, improve your math skills. These types of problems are really great for generating math in context of something, which is important. Math is really boring if it's unmotivated, but when there's motivation for math and why am I doing this? I don't understand why I'm learning calculus. And mathematicians didn't, roughly, let's say mathematicians didn't invent calculus for fun and just for itself. It's so that we could invent physics and we could understand why throwing a baseball acts a certain way. 126, right? So I'll be here, and then I'll often see somebody do the same problem again and get kind of stuck, and I'm like, what if there was a really simple way? I bet that there's I'll show you a secret. I bet you can get this in a flash, in a second. And they're like, wow, how? And, and I'm like, well, guess what? You already did 56 plus 70. Guess what? That's going to be the same as 70 plus 56, right? And then they're like, oh, yeah, that's right. And it's like, oh, okay, so I can just, it's 126, oh. And then I'm like, well, 56 plus 28, you already did that over here too, right? Oh, that's 84. And then they may discover for the first time, this is a cool place to show somebody the concept of symmetry for the first time, motivated by this cool little triangle that was just an addition game. we have symmetry here. It's like a mirror. When you look in a mirror, you get yourself, your face, but it's flipped, right? I don't know if that's the best explanation of it, but the idea is if you find the answer on the left side of the triangle, you know the answer on the right side of the triangle as well. Like the 7 and 21, that's right there. So that's a really cool pattern to show people. Sometimes I start with that, or sometimes I start with the one that Music just mentioned. Thank you, Music. It's cool to be able to stream this with some regulars who know me. I was debating, do I start the stream in my new channel and have nobody show up? Or do I do it with like some regulars who know me for guitar? Music just pointed out one of my favorite patterns to show next, or first. The second diagonal, we get all the numbers forever. 1, 2, 3, 4, 5, 6, 7, 8, 9, ... forever. That's pretty neat. So I like to show that one. That's kind of where it stops. You know, a kid might go home or like somebody can pause and think like, why is that? And it's because you kept adding 1 and 1, and like you get all these ones that are kind of compounding. But then this other diagonal is also pretty interesting. And I think it's so cool because there's two patterns here. One that I know about and I show a bunch of kids. But then recently, some of them pointed out something to me that I hadn't seen before. Usually, especially if there are only the first few rows, some people have noticed, oh, we got a bunch of, these are divisible by 3. Or like, sometimes they just say, oh, they're all multiples of 3. And then they're like, oh, wait a minute, no. Like, oh, no, actually not. And they're like, oh, 1 isn't, and 10 isn't. But this one is, and this one is. Those are multiples of 3. We've got 3, we've got 6, 15, 21. Oh, 28 is not. Oh, how cool. And then I didn't know this one, but it's true. Like, we've got yes, yes, no, yes, yes, no, yes. And like, does this continue forever? And they're like, I think so. I don't know. Maybe? And I'm like, I bet it does. And we do like a couple more rows. And here I could show, like, we don't have to calculate all of the row. We're only interested in this little part, right? 36 plus 9, what is that? And then the kid gets another addition example, 45. It's like, is 45 divisible by 3? And they may have to think about that one. And if you stumble on this one, it's a cool time to remind or show for the first time this. And I don't shy away from showing this funny symbol, sum. Like, I think you can show that to somebody and be like, don't worry, like, I'll explain what that means. Or the bar. Like, a lot of people don't know what that bar means, but that's what mathematicians use to say divisibility. And I would just leave it like this. 3, so a number is a multiple of 3 if the sum of the digits is a multiple of 3. And they might have to pause and think, what does that mean? And it's like, okay, so the number 45, what are the digits of 45? And then they'll be like, oh, and some people know it, some people don't. But I'll be like, oh, it's 4 and 5. If you add those numbers together, they equal 9. Is 9 a multiple of 3? And they're like, yes. And so then I'll say, therefore, yeah, 3 divides 45. And we don't need to know exactly what it is. I mean, 45 is not that hard. I think a lot of people can see that it's 15, or you could run through long division. All we cared about was, is it a multiple of 3 or not, just to check our pattern. And we know what this row is going to be. It's 10. 45 plus 10 is 55. Well, what is 5 plus 5? It's 10. And that is not a multiple of 3, right? So our pattern is working. We've got yes, yes, or like no, yes, yes, no, yes, yes, no, yes, yes, on and on. And you can probably just stop there. I mean, for the right type of person, I think that you could theoretically prove that, but it's not really worth it. It's cool that like we've got this pattern. You get what I mean. And I've never tried explaining it to somebody, but that's one mod 3. We've got remainder 1. We've got remainder 1. We've got remainder 1 on all of those. That's super cool. Like 55. Does that have a remainder 1? I actually don't know. What is 54 divided by 3? Let's just do it. 54 is divisible by 3. 5 plus 4 is 9. What is... I could see it fairly... Yeah, it's going to be 18, isn't it? And I know that because the number 4 there, I know that 3 times 8 is 24. Like, I want that last digit to match. And then, I bet it's going to be 18. 3 goes into 5 one time. 2, 4, 8. Yes. So, that's super cool. This one has remainder 1 as well. That's neat. Okay. Well, that's an interesting pattern. So that's a cool explanation, or that's a really cool pattern I didn't know until recently. But then the other one, I can be like, remember that Fibonacci sequence that we saw once, that I showed you last week or whatever? Well, what about this? 1, 3, 6, 10. These are the numbers here. This is a fun one to show people. I'm like, remember how we thought about that other pattern, the Fibonacci, and like how they added together and there was a pattern in that? Well, how far apart are 1 and 3? 2. How far apart are 2 and 6? 3. And then usually they immediately say, and 4 and 5 and 6. Da, 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 da. And it's like, oh, that's so cool. Like, I bet that you know what the next one is going to be, and then they can just generate a few more. And it's like, that's neat. That's just neat. That's fun. So you can stop there. You can continue, or like the next time you meet or something, or for the right kind of kid or person, adult, anybody. Like this is cool math for anybody, right? There was somebody I was working with recently, like a private student, who knew a little bit about probability. They knew what probability was and counting and how calculating the probability of something. I was like, have you seen this before? And they're like, no, I haven't. I'm like, okay, well, this is the number of ways you can choose K things from N things. So I leave it like that. I don't show the formula for this because the formula, it's not motivated. Like, what I do is I grab 4 pencils. So what we're going to do, little Jimmy, is I'm going to figure out how many ways can I take home 2 pencils out of 4. Like, maybe I've got a pen, I've got a pencil, I've got, sorry for the noise. Looks like I'm missing more pencils, but whatever. I found a third, and we can use... I just saw another thing that would work well. All right. So this is a guitar mute. It works to damp the sound if you want to play at night. All right. Struggling. Perfect. Here's another actual pencil. Okay, so I've got 4 pencils or pens, and you can take home 2 of them. How many ways can we do that? Well, maybe you pick the first one, and then how many options do you have left? You've got 3, right? So maybe we take the first one and we take the second one, or the first one and the third one. This is hard to do in the air, but it's easier on a table. You take the first and the second, the first and the third, or the first and the fourth, right? So that was 3, but maybe you don't choose the first pencil. You take 2 from these. Well, you could take the first and the second, or the first and the third, right? So there's 2. But maybe you don't pick either of those to begin with. Maybe you just start with these. Well, then there's only one way to take 2 of these. So we had 3 plus 2 plus 1, right? There are 6 ways to take 2 pencils home if you have 4 options. And guess what, little Jimmy? Guess what? I'm going to claim that that number is right there. It's right there. It's in this triangle. Because here is when you have 4 items. Here, this row is when you have 5 items. This row is when you have 6. This one's when you have 7. So, well, how many ways can you take 0 pencils home? It's kind of like 1. Like you only have 1 option. Take none of them. How many ways can you take 1 pencil out of 4? 4. Yeah, that makes sense. How many ways can you take 3? Well, that's the same as if you didn't choose 1, so it's also 4. And then I'm like, okay, well then how many ways do you think that you could take 3 pencils out of 7? If I grab an eraser and I grab like something else that it's nearby. So if this row is the one with 7, how many ways do you think you can choose 3? And they're like, 35. It's like, isn't that cool? Like, it was just a little fun addition game, and all you have to do is just a bunch of addition, but this thing can tell you how many ways you can choose things, like counting. And then I usually stop right here, but I leave it at that. I'm like, this is all about counting. This is a math called combinatorics. And there are mathematicians out there whose entire career is to study counting. You learned that recently. You remember 3 years ago or 4 years ago or something, like you were learning to count. Like there are mathematicians out there whose entire career is studying how to count. Like way bigger. We're not talking about like 700 pencils. We're talking like cajillions. They're studying really, really big numbers, but it's still just the math of counting, which is super cool, I think. I don't think that there's anything else I want to say about Pascal's triangle other than, like, again, just really good mental math motivation and something that they can remember and do on their own. So if you just want to practice your addition, this is a fun way to do it. You could see how fast you can do it in 5 minutes. How many rows can you do in 5 minutes? How many rows can you do in 2 minutes? Yeah. Any questions? Anybody in the chat? How's this going so far? Let's get some meta feedback. What are you all thinking? Is this a fun concept? I like it. I like the idea of this. But I don't know, this is a practice run. JC practices, right? That's just way too, like, I'm overdoing it. JC, that's a good question. What do you all think about the handle JC practices math? Should it be JC practices math? I saw that live math or like math live are both available. I don't think practicing math is available. I forget, but the concept is math practice. Right now I'm practicing a math lecture, I guess. But at other times I will be working through problems myself that I'm studying and relearning math, like more complex stuff, and try to explain it, to an appropriate level. It could be like a study stream and we're just listening to music, not just my guitar music, but other people's music as well. I don't know. I think it's a fun idea for 2025. And I can just like live on YouTube all day. I should probably multi-stream it to Twitch as well if we do this, but I don't know. All right. That's okay. No feedback. Let's keep going. Cool. Open question to the chat. Do you want to see Collatz Conjecture? This is a little bit about functions, and it's often the first time I talk about what a function is to people. We could talk about Collatz Conjecture, or we could talk about partitions. Partitions matches what one audience member, John Cesar, was asking about earlier, like the number of ways that you can write down, the number of ways, let's say, that you can split a number. 5 is 5, or 5 is 4 plus 1, or it's also 3 plus 2, or 3 plus 1 plus 1. This is also a really cool opportunity, like showing this problem is a cool opportunity to get people thinking about algorithmic thinking. Like how do you know that you're writing down all of the right ones? Like you kind of have to think algorithmically to be sure that you're writing down things correctly. Like start with a 5, then decrease that and add 1. Okay, if that 4 is fixed, there's no other ways. But then decrease that 1, and then maybe you always pick the biggest number possible, and then you start with that. Okay, then we keep this one the same, and then split that one. Anyways. So then how many ways can you split 2? You can split them. There's only one way left to split that number. And then we're done because these are as small as possible. So now, we can split 3 as 2, and then again, we're going to be picking I usually don't explain this part, so don't get lost, y'all. I just write these out. These are all of the ways that you can write down the number 5. What's cool is that this problem, as well as Collatz, usually people haven't seen this. So I'm guessing that in chat, people recognize Fibonacci that we were working through. I think some people recognized Pascal's triangle. Let me know if anybody has seen this one, Collatz Conjecture, or Partitions. And let me know if you haven't seen it. All right, so last way we can write this one, we can write down 5 is like this. So we're only adding numbers. We're writing down the number, like only using addition. And this is like really easy kid level math, you know? But it's cool. I'm actually going to show you something really cool here. And I bet a lot of people haven't seen this. I'm going to create a table here. Here are all the partitions of 5. And I'm going to create a table. Over here, I'm going to say that an odd partition, which ones only have odd numbers in it. 5. So this one is odd because it only has the number 5, right? So I'm going to give that a check mark. So is the second one an odd partition? No. We could write X's or we could just skip it if it doesn't count. And then point at them. Which ones only have odd numbers? This one and this one. There are 3 options. Okay. Why is that interesting? I don't know. Fun. Thank you for explaining that to me, John. I don't understand where you're going with this. Okay, let's create another thing called distinct. A lot of kids don't know what the word distinct means, so it's a good moment to just say it's really similar to the word different. It's really kind of the same thing. So every number is different in it. All right, well, which ones only have different numbers? Another way to say that is that there's no repeated numbers. We don't repeat. Like here, 1 plus 1, that repeats the number 1. So that one is not distinct. We're going to look at all the ones that only have unique numbers. This one does, and this one does. All of the others repeat a number. This one repeats 1, this one repeats 2, this one repeats 1s. Cool. Well, what if I told you, little Jimmy, that this is always the case? The number of odd partitions always equals the number of distinct partitions. Mind blown. Why? Honestly, why? Somebody in chat, if you understand why this is the case, please explain it to me. This is a good opportunity for me to show a student, an adult student, a kid, anybody. I don't know the math behind this one. I kind of roughly know sort of some of the basic idea here, but I haven't worked through the proof. I don't know the details. But this is just gorgeous, if you ask me. This is beautiful. Why? Why does anything about the number of odd partitions mean anything for the number of distinct partitions? Those are such different ideas that whoa, why? I want to understand that. I want to spend my career understanding that. That's cool. That moment is something I want to impart upon you as a viewer and to little kids or to adults or to a college student. Shout out to jcpractices@gmail.com. I could be your tutor if anybody wants a tutor. So that's a super cool pattern, and that's about it. At this point, I would also probably bring up Ramanujan, Indian mathematician in the early 1900s. And he was discovered by this other mathematician who considers discovering the genius of Ramanujan to be his life's work. This other guy named Hardy. And they together discovered some really, really cool math together, including a lot of open questions and things we still don't understand that Ramanujan predicted about partitions that we still don't understand, and we're still trying to understand why they work. And I wouldn't ever explain this or mention this to an average person, but on my guitar stream, I might mention that Andrew York did some really cool work in this as well, and he has a really great video. So search for Andrew York Acorns if you're interested on YouTube. Cool. Okay, I think I'm about done at this point. I was asking, like, what do you all want to see next? And I forgot to consider doing Collatz. What time is it? It's 12:35. How long have we been live? How long have we been live? I don't know if I can tell. I guess I can see how long ago we started. We started an hour and 20 minutes ago. I think that this is a good time to stop. Collatz is a fun one that I could explain another time, but this is one of those, it's an open problem, meaning, which is a cool idea that a lot of people don't know. Why did YouTube just switch over to another? Weird. I thought we were listening to mine on loop, like the prior video. That's so strange. Okay, so, where are we? My iPad is also, like, literally about to die, like, just run dry on the battery, so that's a bad thing. We shouldn't do that. This is a cool problem to show kids because this is one, like, a lot of people don't know that math is not done. We are still discovering and inventing math and trying to solve problems that we don't know. We're stuck. We've tried understanding this problem for a long time and still don't know. Well, not a long time. It's good to mention that this was like about 100 years ago, not that long, that this pattern, again, patterns, was discovered. And we think that it's always true, but we don't know why. And I'll get into the details next time. Cool. I kind of did this already throughout the entire stream, but this is a concept that I want to reiterate. I'm practicing here. I love the idea of, not JC practicing, JC practices. I love the concept of, I can't spell today, practices. I love deliberate practice. I mean, it's the way that you can learn an instrument. You have to learn how to deliberately practice if you want to get good at any instrument, especially one as hard as classical guitar. But I'm not just practicing guitar on this channel. I'm practicing technology skills. Like, I'm practicing YouTube, quote unquote. I'm practicing live presentation energy. I'm practicing a lot of things all at once here. And guitar is just like one context. It's just one of my deep hobbies. It's my deepest hobby. I see myself learning and studying and practicing guitar for the rest of my life, for sure. I'm super rusty on math. During the pandemic, I really rebuilt math as a habit, and I was like working through abstract algebra problems every day on Dummett and Foote, as well as Lang's graduate algebra, and I audited an amazing course from UC Berkeley of graduate algebra. So I have rebuilt math as a hobby here and there, but recently I've just been 100% focused on guitar. I think it would be super dope to create a brand new channel, JC Practices Math, and go follow it right now. Subscribe to it if that sounds interesting to you. And we'll be doing practice streams like this. This is a practice of a lecture and teaching, but then it'll also be kind of like a Pomodoro stream. Lectures and like study study with me. You know, there will be 30 minutes straight just listening to some classical music or public domain music that people have submitted, and I'll just be working through some textbook problems and then hanging out and chatting with people every 30 minutes. That's the concept, that's the idea. I think it'd be fun. Let me know what you all think. That's it. I think that's everything I got. Thanks, and classical guitar, jcpractices.com. I'm available if anybody is super generous. You know, generosity is infinitely appreciated but never expected. If anybody wants to help support my budding career as an indie content creator, artist, educator, etc., I'm available on Patreon. I'm at JC Practices there. And you can get to it through my link tree. And jcpractices.com currently goes to my link tree, but in the future it might be its own dedicated website. I have a free, totally free habit tracker app called Pixelist that some people really, really love. You can go to pixelist.app in your web browser to jump right to the App Store page. You can go to mujo.app. This one is freemium. It's a one-time purchase if you do want to unlock everything. And it's for musicians. It's kind of like Todoist / Fitbit for musicians. And then finally, if anybody has any feedback, truly, I always say that feedback is a gift. So please let me know what you thought of this in the chat, in the comment section, wherever I can find you. And that's it. I'll play a song for y'all. Thank you for watching this. I think that this was really fun for me, and I hope some people out there enjoy it as well. Thank you for watching. This was super fun. Have a wonderful, beautiful, wonderful day. Bye.